Hey, what's up? This is Scott. Real quick, let's take a look at calculating the moment generating function for the exponential distribution. So to do that, we're going to find the moment generating function, which is going to be nothing more than the expected value of e to the t y for that distribution, right? Now, in order to calculate that, I'm going to write this over here. We're going to take the integral over its support of e to the ty times the function, right? And then just keep in mind that the integral over its support is always going to equal 1. It's going to come in handy. And now here for this function, we're going to have the we're going to have the exponential distribution as our f of x. So we can rewrite this part over here. We're going to have this, negative infinity to infinity, of e to the t y times lambda e to the negative lambda y dy, and then just keep in mind that's going to equal 1, okay? But we don't need that right now. We'll just leave that up. Okay, so what we're going to do is first let's just kind of combine terms. We could pull this lambda out, but I'm going to leave it in here because we know that the exponential is going to have the form of lambda e to the negative lambda y, right? So I'm going to still leave this lambda in here and you're going to see why in a second. So we'll rewrite this. Then we have e. Now let's pull this lambda out to the front here. Now when we have exponentials and we're multiplying, we just add. So what I'm actually going to do is I'm going to pull this negative y out. And then since this is negative, we're going to have we're pulling the negative out, we're going to have y, we're going to have lambda, and then over here, since I pulled a negative y out, this would be minus t, right? Now what we want to do is we're going to do what's called kernel matching, right? So kernel matching is where we say, hey, does this look like something we already know the distribution of? Because if we already know that it fits a certain form, we know that the sum of its function, the sum of it over its support is going to equal 1. So here we have this is the exponential distribution, right? So we have lambda, which we got here. We got a negative. We can also write this as lambda e to the negative y. And I'm going to put this in here like this, so it looks a little bit easier, right? So we've got a negative y. That matches, but this term does not match that term, right? And this, so in order to rewrite this, right, because we could also say that this, right, so your lambda term is going to be in here. So let's just say that this right here is lambda star, right? That means we need a lambda minus t out front here. So now let's just pull that out, right? Let's pull this lambda out because it's not a y. So remember, with an integral, we can pull any constant out. So we're going to pull that constant out. We're going to still sum it over as support. Now what we need is, we need a lambda minus t out here, right? So let's do a little bit of trickery, right? So let's just multiply this by 1, right? But this time we're going to write 1 like this, y minus t over y minus t, right? We know that that's 1, right? I mean, that's just another way of writing 1, right? Because if I put 2 over 2, that's just equal to 1, right? So if I put x over x, that's just equal to 1, but let's just say x is this value, right? So that's just 1, right? So let's multiply this through, and since we want to get a lambda minus t out here, we'll put this lambda minus t here, and since this isn't a function of y, it has no y in it, we're going to bring this y over here. So we're going to be left with this lambda over lambda minus t times this integral So now we have that form of this exponential, right? So let's just call this our lambda star. We've got our lambda star here, And what do we know? We know that the sum over its support is going to equal 1, right? Sorry, this one wouldn't be 1. But the sum of let's put B, A. We know that the sum over its support is going to equal 1. Well, this is in the form of the exponential. So we know that this is a sum over support, which is just equal to 1. So all this is just going to go away. And we're going to be left with the moment of t is equal to lambda over lambda minus t. So there we have it, right? So what you want to do, you're going to take the expected value of the moment generating function of e to the ty, right? You plug it into the distribution, you multiply it by the distribution, right? So we're using the exponential. You simplify the terms. You say, hey, does this match some kind of kernel, right? This is called kernel matching. So it looks similar to the exponential right now. So we just need to find a way to make it look like an exponential. We use a little bit of trickery here, which is just multiplying it by 1. We just rewrite the 1 in another way. Simplify the terms. Now we've got something that's going to sum over a support. We know that the sum over support is 1. You pull it out, and then here's your moment generating function for exponential distribution. Hope that helps. Got any questions? Shoot me an email, or my email will be in the description, or just leave a comment, and I'll be more than happy to try and work some things out for you. Let me know what I can do to assist you. Thanks.